Uh, Today we want to talk about electromagnetic spectrum, which is an atomic physics topic in Form 4. Now, electromagnetic spectrum comes as a result of the arrangement of electromagnetic waves in the order of their increasing frequency or the increasing wavelength. Now, frequency and wavelength are always opposite to one another. When the frequency is high, automatically the wavelength becomes low, becomes small. So an electromagnetic spectrum is as a result of the arrangement of electromagnetic waves in the order of the increasing frequency or the increasing wavelength. Now, what are electromagnetic waves? These are transverse waves formed as a result of the interaction between electric and magnetic fields at right angles at 90 degrees. Examples of electromagnetic waves. There are 7 electromagnetic waves. We have gamma radiations or gamma rays, X-rays, ultraviolet rays, visible light, infrared radiations, microwaves, and radio waves. Now, the gamma rays has the highest frequency and the smallest wavelength. As you move down, the frequency decreases as the wavelength increases. Therefore, radio waves have the highest wavelength as the biggest wavelength, or the longest wavelength, while it has the lowest frequency. Now, the wavelength range from 1 times 10 power negative 13 meters, that is from gamma rays, to 1 times 10 power 5 to 1 times 10 power 5 in radio waves. It is important to note that in the electromagnetic spectrum, there is always an overlap in between any two subsequent rays. For example, if you look at the gamma and the X rays, the wavelength overlap slightly. There is no clear distinction. So as you move, you realize each and every two consecutive radiations overlaps in terms of either frequency or wavelength. As you arrange, when you use in order of increasing wavelength, you start from gamma rays, which has the lowest wavelength, all the way to radio waves, which has the longest wavelength. In the order of increasing frequency, you start from radio waves all the way to gamma radiations. Properties of electromagnetic waves. 1. They travel through space. They travel through space, which is through a vacuum at the speed of light. What is the speed of light? 3 times 10 power 8 meters per second. 3 power 10 times 8 meters per second. They do not require material medium for transmission. They are electromagnetic. They travel through space, hence they do not require material medium, because in space is a vacuum. Space is a vacuum, so there is no medium of transmission. They are transverse in nature. They undergo interference, reflection, diffraction, and polarization. They possess energy in different amounts. possess energy in different amounts given by E equals HF. What is HF? Energy is equal to HF. H is the Planck's constant, whose value is 6.63 times 10 power negative 34 joules second, while F is the frequency of the radiation. For example, if you are talking of visible light, we will talk of energy is equal to Planck's constant times the frequency of visible light. Then they cannot change, they are in charge, they are neutral, hence they are not affected by electric or magnetic field. Thank you. Quote of the day: you are responsible of your own happiness.